Hey you, welcome back. I am filming these videos kind of late, so I'm gonna jump straight into solving this problem. So today I have a moment diagram and a deflection diagram, and we're gonna have to figure out which one is the correct one. So the problem says, which combination of moment diagram and deflection shape most accurately corresponds to the continuous beam with loading shown? In order to solve this, we have to know what is the moment diagram, or better, I should say, the order of diagrams. So saying that, I'm going to go here and I have to tell you I changed the batteries on my pen. So let's see if it's going to work. Let's see. Oh, look at that. It's working. So what I'm saying is, if you remember from your class, when you have I'm going to go with a simply supported beam, right? And you have a concentrated load or a point load. We know that the shear diagram, it's going to be constant, right? In this case, it's going to look something like this, I think. And then, but anyway, the point is that it's constant. And then when you have the moment diagram, we know that the next order of lines is that the moment diagram is going to look, so in this case, it's like that, linear, right? So it's linear. So this is the order of lines, right? It goes constant, linear, and after that is parabolic. And then it's cubic, it's similar to the parabolic. So that being said, in our case, we have a point load, right? And that means that the shear diagram is going to be constant and the moment diagram has to be linear. Okay, so let's identify the linear moment diagram. I'm looking here at, I'm going to start with option D. I'm looking here that the moment diagram looks constant, right? So I know right away that this is not going to be one of my options. Same with option C. The moment diagram is constant, and I know that it has to be linear, so C is out of the question as well. So I'm left with A and B. Now, another thing that I have to discuss with you in order to be able to choose between A and B is that pay attention to, so if my load is pointing down, my moment diagram kind of goes sort of in the upwards, like in the opposite direction. And what I mean by that, I'm going to maybe be able to explain to you better with if you have a simply supported beam. And this is something that we were told like all the way, back in college. And it was something that our professors kind of changed for us. So when we have the moment diagram for this beam, this is constant. I know that the shear diagram is going to be linear. So if I want to draw the shear diagram, I'm going to have my reactions here. I'm going to have going upwards, and then it's going to go like this. So this is linear. And then the moment diagram normally, so also this is plus and this is negative. The sign, right? This is plus and this is negative. And if I was to follow the same direction for the sign or the same positions, plus and negative, I'm going to get the moment diagram parabolic this way. So see how the force goes downwards, and then it almost seems, and that was what we were told in college, that it almost seems that you want to draw the moment diagram this way because, the beam bends, the load bends the beam in this direction. So you almost want to draw it like this. And we did, but what we also did is we changed the sign here. We said we can definitely do that if that's what's easier for us to do, but we have to pay attention to draw the correct sign. So to let people know that we know what we're doing, I will have positive at the bottom and negative at the top. And this, I'm going to put the moment diagram here. So this would be my moment diagram with positive at the bottom, which is similar to the shape that I drew before, where positive was here. As long as you show the sign, it is okay for you to do this. So the reason our professor told us that you can draw the moment diagram this way is that the deflected shape resembles the moment diagram when you draw it like that. So if you keep the moment diagram the way, in the FE exam, you have to know that the moment is going to be, oh, look, they actually are showing here, which I appreciate that. They show positive at the top and negative at the bottom, which is wonderful. Yes. So this is how the sign order is positive at the top and negative at the bottom, right? So if you follow this order with positive at the top and negative at the bottom, the deflected shape is going to be opposite to the moment diagram. So this is the thing that I wanted to share, is that the deflected shape is opposite to the moment diagram. Or if you do it this way, reverse the signs, the moment diagram is going to resemble the deflected shape. And this is the reason why, in college, the teachers kind of told us you can do this, but just remember to put the signs correctly. So now that you know that, we're going to come back here to option A and B that we're left with, and we're going to choose which one is the correct answer. So first of all, we know that the force goes down, the moment diagram is in the opposite direction. That means that the deflected shape is going to be in the direction of the force. I hope I didn't confuse you. I'm trying to stay on point here. Maybe I'll repeat one more time just in case. So I'm going to delete this because I don't want to confuse you. Even though I have made an entire video because somebody actually asked me, why am I drawing the moment diagram here at the bottom when I say positive, but then I draw it in the negative zone? The person that asked me that, he didn't pay attention to the fact that I am actually pointing out that I'm choosing my zones to be which one is positive, which one is negative. But never mind. Here, I would like to keep it the way you have it at the FE exam, and we have it at the FE exam, positive at the top and negative at the bottom. And I'm going to delete this diagram, and I'm going to draw it the way they would have it on the FE exam, and this is positive. There you go. And then based on that, I'm going to draw the deflected shape. So the deflected shape is going to resemble the moment diagram, but it's just going to be opposite way. Okay, so this is how the deflected shape will look for a simply supported beam with a uniform load. Okay, wonderful. So let's now look in our case. We have A and B. Let's look at A. So first I'm going to look at the moment diagram. And I'm looking at the load. The load is pointing out. I know that the moment diagram has to be in the opposite direction. So this option A has the moment diagram drawn in the same direction. And at the same time, I'm looking at the deflected shape. We've discussed that the deflected shape is opposite of the moment diagram. And in this case, if I was to translate this deflected shape here, I would get a deflected shape actually not opposite, but in the same kind of direction as the moment diagram, correct? Correct. So this tells me that option A is not my correct answer. Now, let's look at the B. We're left with B, so obviously B is the correct answer, but I'm going to go over B just to kind of point out the facts that we've discussed before and point out why this is the correct answer. So I'm going to look at the moment diagram and look at the force pulling upwards, and the moment diagram is going downwards. So that kind of tells me that this is one of the criteria that I would choose this option. And then next, I'm looking at the deflection shape. If I was to translate this diagram all the way here, I'm going to actually draw it as best as I can, and it's going to look something like that, which is similar to what we have down here. So this tells me that B is the correct answer. And you don't have to do any calculations. So in this case, you have a continuous beam, so you're not probably able to do the calculations. But even if you're given an example like this, let's say a very simply supported beam, and you might be asked, what is the deflected shape? The first thing to remember is that deflected shape is the opposite of the moment diagram. This is kind of the easiest thing to remember. Another important thing is I want to tell you is that one of these examples actually showed up on the exam, and what it was not a continuous beam, it was a frame. So it's something that you might definitely have on the exam. So I hope this was helpful. I hope you're able to understand. Just because it's a little bit late, I'm kind of in a hurrying up and trying to push this to finish this faster. But I hope this didn't get in the way of me trying to explain this problem in a proper way for you. If you have any questions, please leave them in the comment section below. I'm going to try my best to answer them as fast as I can. Another thing that I want to point out, I haven't talked about this in a long time, but if you are interested in evaluating your education in USA, I have put a guide together with step-by-step instructions on how to do that. So click the link below and you'll be able to download it for free. Or actually, you're going to receive an email. I'm going to send you an email and there's going to be a link in it for you to click and download it for free. Another guide that I have for you is a integral calculus, a few standards integrals with solutions. So if you're interested in that, also the link is underneath this video, so just click on it. Good luck with your studying. Keep up the good work with practicing the FE problems, and I will see you next week.